All right, so hi everyone. I hope everyone can hear me loud and clear.
Yes, I hear you.
All right, awesome. So, what we did in the last session, we talked about what networks are, and we talked about some parameters as well, if you remember. Now, what were those parameters? Those parameters were useful. Well, they were not useful. They are useful for assessing the you know network, right? So what do we have? We talked about performance, we talked about reliability, and we talked about security. And I also gave you two examples. Remember? Do you remember those examples, everyone?
Yes.
So which networks did I tell you to create? A hospital network and a what else?
It's military and hotel.
A military and a hotel. Yes. So for military networks, what did we consider? What was the order of those parameters? Yes, everyone. So what was the order in which we arranged
Security,
them?
reliability, performance.
Security, reliability, and performance. Awesome.
Yeah.
And what about hotel?
Performance, reliability, security.
Okay. And now once we have decided how we are going to go about it, how we are going to arrange those parameters, what is the next thing that we do? We'll have to buy the network devices, right? We'll have to buy networking equipment. Well, before that, we will create something that is known as a topology. So will we start buying devices and start connecting them? Is that what we do, or we do something else? Yes, can anyone tell me? What do we do? So in the last class, we talked about topologies. What are topologies?
It's a bus topology, mesh topology, ring topology.
Right, but what is a topology? What do you understand by a
Okay.
topology?
It is the way the devices are connected to each other, no?
Right.
Con-
Or can I say that it's basically a blueprint? It's a blueprint that I'm going to create and I'm going to share it with my network engineers. We are going to test this blueprint. Now, what does this blueprint contain? Exactly what you mentioned, how the devices are going to be connected. Why do we need to create a topology? Because we can't just connect devices in any way that we like, right? We have to connect them in a specific manner, right? What do we have to do? We need to make sure that the parameters that we have decided for our network, they are met with, right? Our topology is coherent with those parameters. For example, if I want to ensure reliability, I will keep backups of those devices. Am I right? Am I right, guys and girls? What do you think? Right, so this is what we are going to do. So Sai, don't worry about it. We had a demo session last Friday. Okay, so that is when I talked about what networks are. And along with that, I also talked about what topologies are. So I'm going to explain the concept once again for topologies. Don't worry, you haven't missed out on anything. We just talked about what networks are. All right. So what is a topology? Topology is a way through which we are going to connect our devices. So topologies are physical and logical. Before you start creating a topology, physically, you have to first arrange the devices logically. How will you do that? You will do that through the help of tools. You will do that through the help of emulators and simulators. Is it clear to all of you? Clear to everyone? So what is a logical topology? A logical topology is basically a higher level idea of how our network is going to be created or set up. So what will I do? For an example, I am going to open Packet Tracer. This is a tool that I'm going to teach you in the upcoming classes. Don't worry. Since it is already installed on my computer, I'm just showing you what it does. But for our labs, I will help you install it as well. So no need to worry. So for example, I have switches. I have routers. Now what I want to do, I want to make sure that the communication happens no matter what. So here, what I will do is I will connect all the switches together just to make sure that if one link fails, the other link can help me out. So here I'm trying to ensure reliability. Okay. So just an example. So once I've tested this logical topology out, all right, once I've tested this logical topology out, the next thing that I'm going to do is I will get an approval. And after getting the approval, I will get these devices if I don't have them in my organization, and then I will connect the devices physically. So this is how a topology works. This is what a topology is, and this is how we are going to use it in real world scenarios. Now, when we talk about topologies in real world scenarios, we do use these fundamental topologies, but we use some hybrid topologies as well. We use some advanced topologies like 2-tier architecture, 3-tier architecture as well in real world scenarios. But it doesn't make sense to go to the advanced level before discussing what is important and what is fundamental. So what I'm going to do is I'm going to show you some topologies here. Okay. Now I want equal participation from all of you because this is an easy topic and you might have studied this in college or maybe when you were in your school. So this is something that all of you can very easily understand. Okay, so I want equal participation from you. So what is this? This is the first topology. This is a mesh topology. All right. So what is a mesh topology, everyone? A mesh topology is where devices are connected to each other. All the devices are connected to each other. If I have these stations, if this is my station 1, this is station 1, station 2, station 3, station 4, station 5, all the stations are connected to each other. Understood? Now, what do these stations mean? Are they PCs? No. What are these? These could be networking devices, could be either switches, could be routers as well. So when I say station, it does not necessarily mean that these are just PCs. Could be any networking device. Okay. So here all the devices are connected to each other. Great. So I want you to tell me some advantages and disadvantages. Just by looking at this diagram, what do you think are the advantages and disadvantages of this topology? Can anyone tell me? Yes, guys and girls. I'll give you the ability to unmute yourself. If you want to unmute yourself, you can speak it out. Otherwise, you can write it down in the chat box. So any advantages that you think that come with this topology? Yes, Vikas, reliable. Awesome. What else? Okay, on YouTube, Jatin is watching, and Jatin has written that it has too many connections and it is not efficient, right? So Jatin, I have a question. So when you say too many
Go
connections, is
down,
that a
the
advantage?
packet go through another path.
Yes, that can happen. You're right, Shruti. So the packet can go through another path. So is that a advantage or a disadvantage?
Means
Yeah.
it's not completely packet can't be get dropped. So that is the advantage, but going in another path it takes like maybe not really.
When you say going in another path, what do you mean by that? Like this?
Suppose 5 and 4 having one connection, right? So if that is go down,
Yes, 5 and 4 you
then
mentioned. Yeah, this
yeah,
goes down. Yeah,
so it can communicate like through third station.
yes. It can
So
communicate through
communication,
3 and then 5.
yeah, the communication cannot be like not disconnected. That is the advantage.
Right. So yes, there will be some more time involved when the message has to go from 4 to 3 to
Yeah.
5. But then this is because it has to get rid of the problem, right? So I would actually consider it as an advantage, because no matter what happens, your message is still able to reach the other
Yes.
device, right?
Yeah.
Which
Yeah.
means that there will be a small compromise on performance, but the reliability will be intact. The reliability will be maintained. Am I right?
Yes.
Yes. Awesome. Thanks, Shruti. So thanks a lot, everyone, for writing down the advantages and disadvantages. So Jatin, yes, you have mentioned a lot of good points. So I'll also give my opinion. The advantages that I think that are there for mesh topology are: you've got multiple connections, you've got redundant connections, so even if one link fails, the other one can take over, right? So ensures reliability. This is one of the advantages. Then if I have to come up with disadvantages, well, this is very costly. It's not cost efficient, as mentioned by a lot of you. It's going to be very time consuming in case I have to set this up all by myself. Right now, I just have 5 devices, but what if I have 20 devices? What if I have 30 devices? Then setting it up would be a very big hassle. Am I right, everyone? What do you think? That's a disadvantage. Then when something goes wrong, with the topology, then troubleshooting it is also going to be a hassle. That is what I think. Do you agree with me? Do all of you agree with me? If something goes wrong, then localizing the fault, finding out where that fault is going to be a problem. So these are some of the advantages and disadvantages of mesh topology. Now, when you see a mesh topology does not always just look like this, the one that you have seen in the diagram, because a lot of students do what? They just memorize the diagram and then they are not able to differentiate, or they are not able to identify real mesh topologies. A mesh topology just does not consist of only 5 devices. There can be multiple devices, or there can be less devices as well. For example, if I use the same tool, packet tracer, let me open packet tracer, just give me a sec. Yeah. So if I have these 3 switches, I connect them to each other. Is this a mesh topology? Is this a mesh topology, everyone? Yes, because every device is connected to every other device, right? Every device is connected to every other device. So this is a mesh topology. How is this topology helpful? So let's say if the link between switch 2 and switch 0 goes down, there is no problem because switch 2 can talk to switch 0 via switch 1. Okay, so that is how it can work. Abhishek, don't worry about the WhatsApp group yet. This class is still going on YouTube right now. So once we are done and we have our classes from tomorrow, I will set up a group where all of us can talk to each other. And for those of you who have missed the previous session, no need to worry. I will explain each and everything once again. All right. Everyone, no need to worry. So this is a mesh topology. Okay. So now let's talk about the next one, which is a star topology. So what is a star topology? A star topology has a centralized device. Okay. A centralized device which is connected to other networking devices or end devices. We have already talked about end devices. So let me give you an example here. I'll modify this topology a little bit. So what is this? Does this look like a star topology, everyone? One centralized device connected to other devices. Yes. No, it does not. Janil, why doesn't it look like a star topology, Janil? Can you unmute yourself and tell me?
So
It should be
according to
formed in
the definition, it should be like there should be only one centralized device and every single other device should be connected to it, isn't it?
But then there can be modified versions of your star topology as well, right? So it is still a star topology. Yes, it's a hybrid version of a star topology. You could even consider it a tree topology. But originally, yes, this is a star topology, right? Because there is a centralized device connected to other devices, and those devices are acting as centralized devices for their segment. But this is still a star topology.
Okay.
Okay.
Yeah.
Now this is definitely a modified version, but you could consider it to be a star topology, so that's not a problem. So any advantages and disadvantages of this topology? Just like we figured it out together for mesh topology. Let's do it for this one as well.
So if the main device goes off, everything goes off together, isn't it?
Right, that's true.
That can be the disadvantage of it.
Yes, that's true. That's a disadvantage. Yes. So Osmond said that we can have groups. Okay. Too much burden on a centralized device. Yes. Okay, guys. Too many disadvantages. What about advantages? You don't see any single you don't see any single advantage with this topology. There should be at least one, right? Come on.
Yes, sir. Like if you want to send any kind of message to another person secretly, so we can send to a router which we wanted. So it will be not connected to all. So the message will be not distributed all the nodes or stations.
All right. Yeah, that's right. What, Anas? Sorry, could not hear you. Yes, anyone else? Okay, easily scalable. We can save time. Packet would not be broadcast. Okay. What about those who are watching on YouTube? Yes, guys, I want you to come up with some answers as well. So Prakash has written, it is used for small distances. Okay. Now let me give you my opinion. This one is easy to install, easy to configure, easy to troubleshoot. Am I right? If I want to add more devices, I can do that. Right? If I have to make any last minute changes, I'm not saying it's extremely easy, but it would be easier than making changes in a topology like mesh. Making changes to a mesh topology would be very difficult. Whereas in this one, I can make changes very easily. Okay. Then the biggest disadvantage that I see here is something called SPOF. Well, that's an abbreviation. SPOF stands for single point of failure. What does it stand for? Single point of failure. So if the centralized device fails, everything will fail. Am I right, everyone? Okay. So these are some advantages and disadvantages of star topology. Now, why do they call it star topology? Because it looks nothing like a star topology. I'll tell you why they call it star topology, because it's ideally supposed to look like this: a centralized device connected to other devices. So now it's something like a star. Not a very good star, but yeah, something like a star. So this is why they call it a star topology. Okay. So I've explained everything. You can just read the slides whenever you have time, and then you should be able to understand what I explained. And what I'll do is I'll share the slides with you as well so that I don't forget. So there you go. This is for network topology. And this is for introduction to networks. You should be able to find these PDFs in the Zoom chat box. Okay. Now, the next one is bus topology. So what is bus topology? We have a single big data cable which is connected to the stations, which is connected to your end devices. Okay. So what is happening here? You have a single bus cable to which you are connecting your devices, right? And the cable is open-ended, which means you have a cable end here and you have a cable end on the other side. Got it? So this is your bus topology. Now, by looking at this diagram, can you come up with advantages and disadvantages of this topology? Yes, delays and waiting time. Let me give you the ability to unmute yourselves. If anyone wants to unmute themselves and speak it out, you can also do that.
If the cable fails, entire topology fails.
Actually, that would depend, right? That would depend on the quality of the backbone cable. If the backbone cable is not that good, is not of a high quality, then yes, a small breakage will affect the whole communication. But then if it is of good quality, then a small breakage might just affect a part of this topology. Like if it breaks here, then it just disconnects these two stations and the other stations can still talk to each other, right? So, but yes, I will consider that as a disadvantage. If there's a breakage in the cable, then communication can be put to a halt. So yes, what else, guys? Yes. Is that all? Delays, waiting time, transmission failure, what else? Come on, everyone, give me some more points that I can work with. No advantages at all of this particular topology?
Easy to
Is-
configure.
Easy to configure, yes. Easy to maintain, easy to troubleshoot, cheap. What else? Okay, any other disadvantage that you can come up with? If any connection fails, then you have to change the whole cable. Thus, yes, that's right. Okay, I'll tell you one more disadvantage here. But for this, I have to introduce a new concept. And what is that? The concept of simplex. Half duplex. And full duplex. So what is the difference between these three terms? Have you ever heard of this? Have you ever heard of these terms? Simplex, half duplex, full duplex.
Sir, it measures the speed, giga.
No, that is different.
Okay.
That is different. Okay,
Okay.
I'll explain.
Okay. A full duplex is more than 100 Mbps.
Yeah. That's that. But that is based on the speed as well. This is on the mode of communication. So together, the
Okay.
speed and full duplex will tell you
Okay.
what will be the effective speed. But then I'm just asking, what is simplex, what is half duplex, what is full duplex? Okay, no worries. So when we communicate with each other in real life or in computer networking, there are two roles that we can assume. One is of a sender and the other one is of a receiver. Am I right, everyone? You can be a sender, you can be a receiver, you can be a speaker, you can be a listener. Is that correct? Right?
Yes, sir.
So what happens is, in case when you are watching TV or when you're listening to radio, you are always the receiver, right? You are always the receiver. The TV or the radio is always the sender. So the direction of the communication is always in this direction. Sender is transmitting data to you. That's simplex. So when does this happen? When you are watching TV or when you are listening to radio, right? Then there is something called half duplex. Half duplex says that you can become a sender and you can also become a receiver, but not at the same time. Okay, so it's like a switch, not a networking device like the switches at your home, either on or off, like the switch that you have for fan or for light, right? So it can either be on or off. So similarly, you can either be a sender or a receiver. So if you are the sender, the other person will become receiver. And when they become the sender, you will have to become the receiver. So what is it? It is unidirectional, but not always unidirectional, depending on what role you have. So if I am the sender, you will become receiver. If you are the sender, I will become receiver. Understood? So an example of this is walkie-talkie. On walkie-talkies, what do? One person will first speak and then the other person will speak.
Oh.
Right, everyone? Am I correct? So this is what happens in half duplex communication. And what can I do? If I use the security option in Zoom, where you cannot unmute yourselves. Can you unmute yourselves, guys? Try unmuting yourselves. Can you do that? No. Why? Because I've removed that option. After after removing that option, what is happening now? Only I can speak and you can listen. Only when I give you the ability to unmute yourself. For example, I give Abhishek the ability to unmute himself. So Abhishek, can you now unmute yourself? Say something. I'll be quiet. Say anything. Say hello, hi.
Hello.
Yeah, great. So when he's speaking, I will stay quiet. I will become a receiver. And when I'm speaking, what I can do is I can mute him. So this is what half duplex is. Half duplex means that you can become a sender and a receiver, but you cannot become both at the same time. Is that clear to all of you? You cannot become both at the same time. That is just not possible. Clear to all of you? Clear to everyone? Awesome. And yes, Anil, it is used in military operations. Finally, what do you have? You have full duplex. Full duplex is where you can become sender and the receiver at the same time. It's like when you're on a phone call, when you're on a WhatsApp call, when you're on a Zoom call, Right now you're not on full duplex. Now if I give you the ability to unmute yourselves, if anyone wants to unmute themselves and have a discussion with me, we will be on full duplex. So anyone wants to talk to me? Yes. Yes.
Hi.
Yeah. Yeah. This is full duplex. This is what General did. Both of us are able to talk to each other and listen to each other at the same time. We haven't restricted. We haven't restricted each other from doing this or doing that. So this is what this is known as full duplex, right? Communications that happen these days in the modern era, they're full duplex. They are full duplex. Are you getting my point? But initially, when computer networking was introduced, it was half duplex. Now, why did I change the topic from topologies to simplex, half duplex, and full duplex? It's because bus topology could only support half duplex, which means if this is the sender, others will have to become receivers. So now there is a huge delay. If this station number 3 wants to say something, station number 3 won't be able to say anything unless and until it becomes the sender. So that is the problem with half duplex. Also, let's say this station 3 is not aware that it has to become the receiver, and it sends the data at the same time as station 1. At one point, their data is going to meet. It's not just going to meet, it's going to collide. And then what is going to happen? It is going to destroy the data. This is called collision. Clear to everyone? Yes, Lakshmi, you had something to ask or say. Please go ahead. Do you have any questions, Lakshmi? Nope. Okay. So this is one of the problems with bus topology. So did everyone understand what bus topology is and what are the problems with bus topology? Now, I was expecting a question from all of you, like, is bus topology used in real world scenarios? So to be very honest, in the modern day scenario, there are not any, true uses of bus topology. There is something called legacy topology. Legacy means that was something that was set up in, let's say, early 2000s, and it is still in use because they did not migrate it to a new topology. So they are still working with bus topology. Let's say a company created bus topology for their network back in 2000. And since it has been working fine for them, they did not make any changes. It's 2023 right now, and their topology still works fine. So there is a common saying that if it is not broken, there is no need to fix it. All of you must have heard that. Yes or no? Have you heard of that saying? So if it is not broken, no need to fix it. Right? So there are some topologies, very few, extremely rare, that are still working with bus topology. But right now, if I have to set up a new topology, I won't be using bus topology. So in the past, we used to work with something called thick net and thin net. And we used to have something called T connector. And because managing bus topologies was also a pain. Okay. So that's why we don't work with them in the modern era. Are you getting my point? In the modern era, we don't work with bus topologies. Where will you find bus topologies? If you go and study books related to computer networking, They will explain you, they will give you a scenario where to a specific cable, they have connected servers, they have connected workstations, they have connected printers. But in 2023, I don't see any organizations working with bus topology, right? Are you getting my point? So there's a question asked by Vikas on YouTube. So Vikas, when you say does data travel as 1010 or high low voltages, it depends. So on machines, it will work as binary. Okay. But when it goes through cables, Vikas, it will travel in the form of signals. Now it depends on what kind of cable you are working with. Are you getting my point, Vikas? So if it is a fiber cable, it will work in the form of light signals. If it is a copper cable, it will work in the form of electric signals. Okay. But when your data is transferred to the machine, that data, the same data is understood in the form of zeros and ones. Clear? Okay. So I talked about the advantages of bus topology and advantages and disadvantages of bus topology. All right. So we will now talk about ring topology. So Jet Carl, he has asked a question, how about in fiber deployment where we're using bus topology? Like I said, there are scenarios where bus topology is used, but it's not extremely common. Are you getting my point, Jet? It's not extremely common. If we talk about organizational networks, the networks that we are going to deploy inside the data centers, inside my organization's infrastructure, I won't be thinking of a bus topology. Plus, when we talk about CCNA, CCNA is more of, you know, networking, which is performed in organizations. So I never said that we don't work with it anymore. I'm saying that there are some deployments, but they are not very common. All right. Okay, everyone. So don't worry. These questions are not on Zoom. These questions are on YouTube. So now the next topology is a ring topology, everyone. Now, what is ring topology? Ring topology is your modified version of bus topology. Am I right or wrong? What do you think, guys and girls? Seems like everyone is super quiet. Guys, I like the sessions to be interactive. The last message that I got was at 8:39. Since then, I haven't received any message in the chat box. Okay, now I got a message from Osman and Abhishek. Awesome. So your ring topology is what? Your ring topology is a modified version of the bus topology. So looking at the diagram, can you think of some advantages and disadvantages of this topology, everyone? And while you do that, just give me a minute. I'll be back. I'm going to drink some water and I'll be back. Till then, you keep on writing your answers in the chat box. I'll be monitoring the chat boxes. All right. All right. So let's check everyone. Advantages, yes, the network will be available. Disadvantages, well, one more advantage. Easier troubleshooting of networks, yes. This is on half duplex. Data can be destroyed. Now again, it depends on the kind of cable that you're working with, right? It completely depends on the cable that you're working with, everyone. Okay. So let me check on YouTube. Anyone claps or okay, anyone flaps. Okay, my bad. Yes, that is not entirely a disadvantage. If any device is not working, it will not affect the whole network. Let's say this particular device fails. The cable is still intact, right? There is nothing that is going to happen to this cable. So I see a lot of problems with this. Number one is that since there are a lot of devices, okay, since there are a lot of devices, let's say this device has to send a message to 1, 2, 3, 4, 5, 6. Now, when one has to send message to 4, because the message has to pass through a lot of devices, right? The message has to pass through a lot of devices. So by the time the message reaches device number 4, by the time the message reaches device number 4, what is going to happen? No, not collision. The quality of data would have been reduced significantly. Are you getting my point? The quality of data would have been reduced significantly. So in order to take care of that, what is used? A repeater. To boost your messages, to boost the signals, a repeater is used. Are you getting my point, everyone? Because one has to send message to 4. There are two ways to do this. 1 to 2 to 3 to 4, 1 to 6 to 5 to 4. In any scenario, the message has to pass through other devices as well. So generally what can happen is the message quality, the quality of the message can be reduced significantly when it has to travel through multiple devices. So in order to take care of this problem, what can be done? A repeater can be used. Another advantage, this is not very difficult to set up. It's just close-ended. Yes, Prakash on YouTube has mentioned that if there are any points of failure, they can be identified. That's also a great point. Right. Then if there is a breakage in the cable, it can affect what? It can affect the communication. Then you guys mentioned that it is working on half duplex. So when it is working on half duplex, it can lead to collisions. But then the creators of this topology came up with a brilliant concept that they will convert this topology into full duplex. And that full duplex topology will be known as dual ring topology. What is it known as? Dual ring topology. So what do you think? Are we using 2 cables in dual ring topology? Yes, guys and girls. What do you think? Are we using 2 cables in dual ring topology? Yes, Ganesh, what do you think?
No, sir.
No, so what is it that we are using? How are we making it dual ring? How are we making it full duplex?
I think is any backup.
No, not really. See, in a cable there are wires, right?
Yeah, copper or
Right.
fiber cables.
Any cable. Even if I take an example of my phone's charging cable,
Okay.
right?
Hmm.
There is going to be what? There is going to be bunch of wires inside it.
Okay.
So what happens? How do you make a topology full duplex? Inside your cable, you let some of the wires send data and you let the other wires receive data. This is what happens in Ethernet as well, right?
Yes.
This is what happens in copper cables as well.
Yes.
So four wires will send data, 4 wires will receive data. That's how it works. Got it?
Yes. Yes.
So this is how we make a ring topology a dual ring topology. Clear to everyone? Understood, everyone? Any doubts in these topologies? I hope it is clear. Awesome. So then what do we have? We have something called hybrid topology. So what is a hybrid topology? Hybrid topology is just a combination of the topologies I have mentioned. So when you look at this topology, what is it like? Which two topologies is this a combination of? Can anyone tell me? Yes, you're right, Janal. Star and bus. You're absolutely right. So this topology is a combination of star and bus topology. So now, yes, there is a single point of failure, but that single point of failure will not affect the communication between or within the single bus. So if this is my bus 1, let's say this is bus 1, this is bus 2, this is bus 3. If the centralized hub fails, then it will only affect the interconnectivity between these buses. It will not affect intra-connectivity. The buses will still continue to work. Right? The buses will still continue to work. Is that clear to everyone? Then if there's a problem in one bus topology, the others are not affected by that. Let's say if bus topology 1 fails, 2 and 3 are still able to talk to each other. Right? Sure, Janil. Like, which one? The first point that I mentioned or the second one? The first one? Yeah, sure. So let's say the hub fails. Right? Now these buses are working fine by themselves. Why have we connected these 3 buses so that they can talk to each other? Let's say I have certain devices. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that 1 can talk to 4 or 1 can talk to 5 or 5 can talk to 7 or 5 can talk to 8. We are using a hub. Right? We are using a centralized device here. Could be any other device as well. Just a centralized device would be fine. Don't have to say that it's a hub or something else, just a centralized device. Okay. Now, if this fails, if this hub or this centralized device fails, others can still function properly. Like the bus topology, where you have these 3 devices, 1, 2, and 3, they can still talk to each other. 1 can talk to 2, 2 can talk to 3, 4 can talk to 5, 5 can talk to 6, 7 can talk to 8 and 9, 8 can talk to 7 and 9. It's just that interconnectivity will be a problem. Otherwise, they are working fine. Did you get what I'm trying to say, Janil? Okay. So this is the advantage. All right. This is the advantage of this topology. So folks, this is what I had in mind for today's class. All right. Now, when we meet tomorrow, the first thing that we are going to do is we are going to create a group, because today's session was on YouTube as well. Okay. So tomorrow we are going to create a WhatsApp or a Discord group. I'm going to share all the notes in the class tomorrow. Okay. And yeah, that's how we are going to proceed with the course. And then I'll give you the ability to unmute yourselves. So Anil, no need to worry. I'll explain whatever you have missed. You will get the recordings of all the classes. They will be available on my.nwkings.com. Everyone, you don't need to worry about it. Mostly in real life, we use mesh. We work with mesh. We work with star. We work with ring as well. Bus, like I said, bus is obsolete. And mostly in real world scenarios, Abhishek, we work with hybrid topologies. Okay, we work with hybrid topologies. And the topologies that are in use these days, that are very common these days, are known as 2-tier architectures and three-tier architectures. So that is what we work with in the modern era. Understood, everyone? Is that clear? And then coming to the questions on YouTube, so Prakash asked this question, which is better to use between ring and bus? So Prakash, it's definitely going to be ring, because like I mentioned, bus is obsolete. And then just don't always think between bus and ring, because you can create a hybrid version of the topology as well. Okay, you can create a hybrid version as well. Understood? So that would be better. Just give me a second, Shruti. Yes, Shruti.
Hi. So other than this class, what we need to do so we can get perfect in this networking concepts?
You don't need to worry about it. I have all the labs. I have everything. Okay, I will be sharing those labs with all of you tomorrow. So when we will be going through the course, you will get access to Mr. Atul Sharma's videos as well. So if you revise that content every day, if you go through the labs every day, that will be more than enough. Okay.
Okay, and there will be some like volume 1, volume 2, like we have notes, right? Online,
You have notes. See, everything
like so
online. Everything
need
is
to
there.
prefer that one.
I have already prepared that for you. You don't need to worry about it.
Okay,
All right. I have all the material.
yeah. Okay.
Okay. All right.
So every day at 8 p.m. right?
Every day at 8 p.m. Yes.
Okay, thank you.
So Michael, don't worry about it. Yes, there will be course material. There will be everything. It's just that I want to create a group first, a Discord group, or what is it? A WhatsApp group. And once I've created it, I'll upload all the material there. Okay. I'll be uploading all the material there. Cool. So Abhishek, can we talk about it tomorrow? Because I have another session at 9. Is that okay with you? All right. So we'll have a discussion tomorrow. Cool. So, all right, everyone. Thank you for attending this session. And thank you to everyone attending this session on YouTube. I hope you liked this session. So if you liked it, well, keep on supporting us so that we can come up with some cool content for you guys. All right. So thank you, everyone. Bye-bye. See you tomorrow at 8 p.m. IST. Bye-bye.